Okay, good. So my presentation is visible to everyone.
Yes, sir.
Okay, okay, good. So my presentation visible to everyone, correct? Okay. So once again, good evening to all of you. So today we have a first class of the modeling and control of the electrical drives, and now you are in the second semester of the MTech program. Okay. So first semester we completed. I mean, you completed the first semester, and now this is your second semester. And this is our first class of the modeling and control of the electric drives. Okay. So I am not uh, going to detail about my education profile, because last semester we already discussed the my education profile, my research domain. So this research domain is most important because from the third semester you have to do your MTech thesis, correct? And MTech thesis is most important for the MTech scholar, yeah, MTech research student. So you have to decide your research topic, otherwise we can say the research domain. So on the what topic you have to do your research, correct? And that is a, I think, 1 year thesis. Okay. So I already discussed with Jitendra sir, and he told in the Nepal also there is a 1 year MTech thesis period. So you have to choose any research domain, any research topic, maybe the power system, maybe the power electronics, yeah, maybe the electrical drives, yeah, any renewable energy. So related to your branch, and branch is a power electronics and electrical drives, correct? So that's why I'm showing this research domain. Suppose you want to work with me, then that is also possible. So we can do the collaboration with your institute and my institute, and then we can start your research. Okay. So student, please choose your research topic for the MTech thesis, and that is the most important part. Okay. So that is a starting from the third semester, not the second semester. But suppose you want to do the good research in the MTech, then you have to start your research from second semester. Okay. So that is a good way. So maybe you can consider the power electronics and electrical drives, yeah, electric vehicle, hybrid electric vehicle, and you can consider the acoustic noise and vibration of electric machine for your MTech thesis. And my suggestion is you have to select the special electrical motors, not the induction motor and DC motor. Okay, so nowadays people working on the special electrical machine, and already Professor Rajpurohit is teaching you this subject, that is a special electrical machines. So you will study details about the special electrical machines, that is a PMSM, BLDC, SRM, synchronous reluctance motor, and many more motor. Okay. And then you can also select the condition monitoring and fault diagnosis of the electric machine, and that is a, this is the hot topic nowadays. So suppose your motor is going to damage, so before going to damage you will see the signature of the your uh, motor, correct? Then you can say now we have to shut down our motor, correct? And then you can see, you can take the any decision to stop your plant. Okay, done. So that is the most important part. And also you can take a research topic on the renewable energy, so as per your choice. Okay. So these are the my research domain. So maybe you can take any faculty member as a guide, maybe the Jitendra sir, maybe me, maybe the Bharat sir, any research supervisor for your MTech thesis. Okay. So that is up to you. Okay. So this research domain is important for your second semester as well as the third semester. Okay. Now, course evaluation scheme. So this is the same for like previous semester. Internal assessment, that is a 20 marks. Okay, there's a 20% weightage. Assignment, that is a MATLAB simulating. So we have to perform the minimum 7 to 8 experiment and maximum I think 12 experiment. Okay, so now you already learned the MATLAB simulating and now already you know about the MATLAB. Okay, so I am planning to do the MATLAB uh, experiment around 7 to 8, that is a minimum, and maximum 12 experiment in the MATLAB. Okay, so that is a very good experiment. So there is an advanced level experiment also. So whatever you learned in the first semester, that is a basic and fundamental concept of the MATLAB. Okay, now you already learned the MATLAB and the simulating and fundamental of the model, how we can modeling the any electrical machines in the MATLAB. So now we can start from the first experiment, that is a control of the electrical drives, correct? So that is a 20 marks. So 20 marks, that is an internal assessment, and 20 marks, that is your MATLAB simulating assignment. And remaining 60 mark, that is your final semester exam, and that is conducted by the IOE. Okay, and this attendance is a 75%, that is a minimum attendance. It is compulsory as per your institute rules and regulation. Total internal assessment mark is 40. There is a both first and second, and passing mark, that is a 20. Okay. So suppose you want to appear in the final semester exam, then you have to get the 20 marks, that is a internal assessment, that is a 50 marks. Okay. Yes, you all are the intelligent students, so no issue. So internal marks 20 marks, I hope you will get in the second semester also. Student who pass the internal assessment can only appear in the final semester exam. Okay, so there is a most important thing. So internal marks is a 40 marks. Out of 40, you have to uh, get the 20 marks. Then you will appear for the final assessment. Okay. So till now, any confusion, any doubts? Okay, I hope this is a clear for everyone because this is a second semester. Okay. Now I am coming back to the syllabus. Okay, so my PDF is visible to everyone. Yes, student, my PDF is visible to everyone.
Yes, sir. It's visible.
Yeah. Okay, so this is our syllabus. There is a subject name is a modeling and control of the electric drives. Okay, so main thing is a course description. Why we are going to study this subject, that is a modeling and control of electric drives. Okay, so before going to discussion of the detail of the modeling and control of electrical drives, any one student please tell me what is the meaning of modeling, control and electric drives. Yeah, starting from the girls, maybe the Archana, can you just tell me the what is the meaning of modeling? Yes, Archana is there.
Yes, sir.
Yeah, can you just tell me the modeling? Because in first semester we already studied the modeling of the analysis and modeling of electrical machines, correct?
Modeling means mathematical description that represent the behavior of device.
Represent the behavior of the device. Okay, okay, good, very good. And Isa, what about the control? Whenever we can say the control, so what is the meaning of control? How you can define the control as a electrical engineer, as a MTech student? How we can define the control?
So control means after giving certain input, observing the output of the system and taking necessary measures to improve the system behavior parameters.
Okay, very good, very good. So nice answer. Manoj Wagle, as a we have a electrical drives. So how we can control the electrical drives? Otherwise, what type of parameter we have to control in the case of the electric drives? Can you just
So we use electrical drives to control the electrical parameters like voltage, current, or any parameter to control the speed or torque of the motor, sir.
okay? So what type of parameter we have to control?
Current and voltage, sir.
Current and voltage. And suppose you want to control the speed, then what type of parameter you have to control?
Current,
Current. And suppose you want to control the torque, then
voltage, sir.
are you sure?
This I might have what?
Yes, Narayan.
Uh,
So Manoj
Yes, sir.
Wagle is correct. Are you agree with Manoj
Mm.
Wagle? So he said, so
I
suppose
think
you want to control the speed, then we have to control the current. And suppose we want to control the torque, and then we have to control the voltage, not current.
no, sir.
So
I think to control
I'm
speed,
wrong.
we have to control voltage, and to control
Yes.
torque, we have to control current.
yes, so student, this is a most important as a MTech student, as a power electronics student. Suppose you want to control the speed, then we have to control the electrical quantity, and that is a voltage. So voltage is directly proportional to the speed, correct? So because motor is a mechanical device, correct? And whenever we can say drive, and then we can say it is a power electronics, correct? So whenever we can say power electronics, then we have a quantity that is electrical quantity, and that is your voltage and current. So that is a fundamental and thumb rule. We can say, suppose you want to control the speed of the motor, then we have to control the electrical quantity, and that is a voltage. Suppose you want to control the torque, then we have to control the electrical current. Okay. How we can control electrical current, how we can control the electric voltage, and that is a role of the drives. And then we can say it is a drives. Okay. So drives means we have to control the electrical quantity as well as the mechanical quantity. Then we can define the it is a drives. Okay. Just 1 minute. Yeah, Alok. Okay. Okay, so in the summary form, we can say subject name is a modeling and control of the electric drives. So modeling, we can say we have to analysis the mathematical model of the any machine. Okay, maybe the generator, yeah, maybe the motor. Okay, whenever we can say machine, then machine is depend on the two quantity, that is a motor, otherwise the generator, correct? So motor, there is a nothing but the electrical quantity into mechanical quantity, and generator, it is nothing but the mechanical to electrical quantity, correct? Control means we can give the input parameter and we have to take the output parameter. Okay, so suppose input is a torque, so output is also torque, so we have to control the torque. Okay, so suppose you want to control the torque, okay, then we can say it is a controlling of the torque. Suppose you want to control the speed, then we can say the controlling of the speed. So across the globe, we can say whenever we have an electrical motor, always we have to control the torque, otherwise the speed. Only two quantity. Okay, done. So course description, that is this course explore the principles, methodology, and application of modeling and control techniques in the electrical drives. Okay, so in the first semester we already studied mathematical modeling of the AC motor and DC motor as well as the synchronous motor, correct? In this subject, we are going to detail analysis of the same motor, that is a DC motor, a synchronous motor, and the AC motor, that is an induction motor, correct? So in the detail analysis, correct? In the first semester, we just learned the overall overview of the modeling, correct? But in this semester, we are going to study the detail analysis, detail modeling of these three type of motor. That is the first part. Second part, these electric drives play a pivotal role in the various industry application, including robotics, electric vehicle, and renewable energy system. So how we can use the electric drive in the various domain, we can say in the robotics application, electric vehicles, and renewable energy system. So we will learn in this subject, okay, how we can use our electric drives in particular this application. Third objective, the course emphasizes the integrating theoretical concept with the practical implementation to equip student with a comprehensive understanding of the electrical drives. So end of the subject, end of the course, you will able to learn the integration of the theoretical concept as well as the practical knowledge, correct? So practical knowledge, whenever you perform the experiment in your lab, then you will get the practical knowledge. Okay, done. And theoretical knowledge in the class, and as well as the like hybrid knowledge, we can say the simulation knowledge that you will get from the MATLAB. Okay, so major three objective. First one is the detailed principle and methodology of the different type of motor, that is AC motor and DC motor as well as the synchronous motor. Second part, we will learn how we can use this motor in the different application, maybe the electric vehicle, maybe the renewable energy system, and maybe the robotics, correct? So this is a simple example of the application of electrical drives. And last one, you will able to understand the theoretical concept of the drives, and then you can implement this concept in the practical application. Okay, so that is a course descriptive of the modeling and control of electrical drives. Okay, prerequisite. So before going to start this subject, you must aware about the fundamental concept, correct? So that we already cover in the first semester, also that you already cover in the BTech, but most of the student completed BTech program before the 2 to 3 years. Okay, yeah, more than the 5 years, correct? But I'm not going to detail about this BTech course, but I already taught you about the fundamental of the electrical drives as well as the modeling, correct, in the first semester. So fundamental, suppose you forget the fundamental, then again you have to revise, just revise your concept, that is a foundation understanding of the electric circuit. Okay, just revise your concept of the electrical circuit, what is electrical circuit. Okay, then electrical machine, how we can define the electrical machine, that is a generator and motor. We already covered this topic, we took already through to 3 class on the electrical machine, how we can start the electrical machine, how we can classify the electrical machine. Suppose you forget this concept, then just revise my lecture notes, okay, of the first unit of my lecture notes. So you will again revise, you can again recall this fundamental concept. Then power electronics converter. Yes, in the last semester we did not cover the power electronics converter, but I hope you cover in the different subject. Yes, Manoj Wagle, did you cover this power electronics converter in the first semester in any subject?
Yes, sir.
In which subject?
Power electronics, sir.
Your power electronics, that is a subject in the first semester, correct?
Yes, sir.
And that is a advanced level power electronics converter. Yeah, that is a simple power electronics converter.
Advanced power electronics was the subject. We discussed about few power electronics converters, sir.
Okay, so buck boost converter, Kirk
Yes, sir.
converter, you already studied?
Yes, sir. We study in brief, sir.
Okay, good. So that is a very good. That power electronics converter knowledge is also important. And electrical drives. So in the previous semester, we already studied about the electrical drives, how electrical drives working, and what are the major parts of the electrical drives. Okay. So in this subject, we will study the detailed analysis of the electrical drives. Okay. And finally, the control system. Okay. Whenever we can say drives, it means it is a, we have to control the two parameter, maybe the voltage and maybe the current. Okay. And whenever we can set the mechanical parameter, then we have to control the your speed and torque, correct? So this type of fundamental knowledge you should know, then we can say now we can start with the advanced level course, that is a modeling and control of the electrical machines, yeah, electrical drives. Okay. Assessment method I already discussed. Okay, assessment method maybe include the assignment, maybe I will give you assignment, maybe quiz, midterm exam, final project, and comprehensive final exam. Okay, so these are the assessment method. Okay, so during the semester maybe I will give you the 2 to 3 assignment, maybe I will take the online quiz. Okay, and 100% there is a one midterm exam, okay, and there is a final evaluation, okay, and one final project that is based on your MATLAB Simulink exam, okay, that is your final exam, and that is your final MATLAB exam, okay. So these are the assessment method, okay, and learning outcome, okay. So suppose you will attend this course during the semester, maybe we can say the 4-month time period. So what type of topic you will learn from this course, okay. So by end of the course students will able to learn, okay, so end of the course, so total 6 topic. Understand the fundamental principle of electric drives and their component, that is the most important thing, and that is with respect to also placement, with respect to your job, okay. Understand the fundamental principle of electrical drives and their component, okay. Then develop the mathematical model for the different type of electrical machines. Mathematical model we already studied in the first semester, but again these are the advanced level mathematical model, correct. So we can say that there is a reference frame, we have to convert into dq transformation to alpha beta to abc, that is a advanced level, okay. Second parameter. Third parameter, analysis the motor situation during the starting and braking, okay. So whenever we can say the starting and braking, that time what happened with the motor resistor, what happened with the motor inductor, what happened with the flux, what happened with the torque, what happened with the speed. So this type of parameter we have to analysis, okay, using the drives, okay, and we will perform this experiment in the MATLAB also. Fourth one, estimate the motor rating of the different condition of load, okay. So we have to estimate the motor rating for the different condition of the load. So yes, Rachak is there. Rachak, are you there? Okay, so how we can
Yes, sir.
define the transformer rating? What is the rating of the transformer, unit of the transformer rating? And whenever we
KVA.
can say the motor rating, then it's the same like KVA rating, yeah, another different rating.
For motor, it's used. For three-phase motor, it's KVA.
Okay, and for single phase,
For single phase, we use kilowatt.
kilowatt. And for why single phase kilowatt and 3-phase KVA?
Mm, I don't know that, sir.
Okay, good try. Yeah, yes, Manoj, any idea? What is the rating of the motor? How we can define the rating of the motor?
Usually motor are rated in kVA, sir.
KVA, and what about transformer?
Transformer also kVA, sir.
KVA, very good. So single phase and 3-phase motor both are KVA?
Usually transformer are rated in kVA and single phase motor are rated in kilowatts, sir, or watts,
Mm-hmm.
and three phase are rated in kVA.
Why?
I can answer that, sir. I don't know.
Okay, yes, Madhusudan. Yes, Madhusudan, are you there?
Yes, sir. I'm
Yeah.
here. I
Any
think
idea?
loads are loads has different characteristics like lagging nature, leading nature, and we don't know about the about what the purpose the motor is going for. So uh, so motors are rated in three-phase motors are rated in kVA.
And what about single phase motor?
I don't know, sir.
Okay, so partially your answer is correct. So you are telling like single phase, 3-phase motor rating is KVA because we don't know the what type of load we can connect. Correct?
Yes, sir.
Okay. Yes, Isa.
Yes, sir.
Do you have any idea?
So I think motors are rated in kilowatt, not in kVA.
Okay, maybe the single phase or three phase, any type of motor.
Yes, sir. Any
Okay.
type of motor,
And
I
transformer,
think. Transformer kVA.
kVA. Okay, good. And why? Both are the electrical device.
So I think motor has fixed power factor,
Motor,
is certain power factor, or I don't know, sir, exactly.
okay. And what about transformer? Any idea for transformer?
No, sir, not now.
Okay, good. Any student? Any idea? So why kVA and kilowatt? Any idea? So his answer is correct. So motor rating is a kilowatt. Maybe the single phase or three phase. So motor rating is always kilowatt, kW. Okay, and transformer rating is always kVA. Okay, so any justification? Any student? Any justification? Okay.
Type of load to be
Yes.
supplied by transformer not known, so that power factor was not fixed. So it was rated in kVA. But for motor, that power factor was fixed, so that they are rated in watt.
Yes, correct. Very good. So in the case of the motor, there is a power factor is a fixed, correct? And we know that is load, what type of load we have to connect. So power factor is not very correct. So load is fixed. But in the case of the transformer, we don't know what type of power, what type of load we have to connect. Correct? Maybe the inductive load, yeah, maybe the capacitive load. And this power factor is depend on the both load, correct? Inductive load and capacitive load. So we can say generally we have a three type of load: inductive load, capacitive load, and resistive load. Whenever we can say the resistive load, then power factor is unity, there is not issue. But whenever we can say the inductive load and capacitive load, that is your current is leading and lagging with respect to load, correct? So that's why transformer rating is a kVA, because we don't know which type of load customer will connect with the power with transformer, correct? Maybe the inductive load, yeah, maybe the capacitive load. Okay, so that's why it is always rating on the kVA. But motor, that is not depend on the power factor, because we have to connect only load, that is your mechanical load. So that is not depend on the power factor, correct? So that's why that rating is a kilowatt. Maybe the watt, there is a single phase motor. Yeah, maybe the kilowatt, maybe the three phase motor, correct? So always rating is a kilowatt. So fourth point, that is a estimate the motor rating for the different condition of load. So we have to apply the different condition of load, and then we have to define the motor rating. Okay, and various type of load we will study in the first unit. And then fifth one, implement control strategy for the different operation of electrical drives system, correct? So we have to also implement the different control strategy for the efficient operation of the electric drives. Okay, so there is a, so you must know about the control system concept. Okay, so just clear about the open loop as well as the closed loop control system. Suppose you forget about this concept, then just revise about the open loop and closed loop control system. Okay, then sixth one, that is analyze and simulate the dynamic behavior of the electric drive. Okay, so we have to also analyze and simulate the dynamic behavior of the electrical drives. Okay, so that is the most important part, dynamic behavior. Yes, Narayan, what is the meaning of dynamic and steady state? Yes, Narayan,
Yes, sir.
what is the meaning of steady state and dynamic?
Yeah. Dynamic behavior means suddenly change,
Okay.
sudden change,
Mm-hmm.
and steady state means comes to steady state after some disturbances or after some transient.
Okay. Okay. Steady state means?
Steady state means comes to steady state after some transient or some disturbances.
Okay, good. So dynamic means that is your response will change with respect to time. That is not a stable response, correct? That is a dynamic operation. And steady state means that the response is a constant with respect to time, correct? Suppose you are your vehicle and your vehicle speed is a constant 100 kilometer per hours. So that is your steady state operation, correct? But dynamic means suppose your vehicle speed is not a constant, maybe the 60 kilometer per hour. It is a vary with respect to time. Maybe sometimes it's a 50 kilometer, sometimes it's 70 kilometer, sometimes it's 10 kilometer per hours, correct? So that is a dynamic operation. So we have to analyze and simulate the dynamic behavior of the electrical drives, correct? And finally, apply the knowledge to solve the practical problem and design the effective drive system. Okay, so these are the final learning outcome. Whatever you learn from this subject, so finally you have to apply your knowledge to solve the practical problem. Okay, and design the effective drive system. Whenever we can say effective drive system means your efficiency is near to the 100%. Okay, yes, in the ideal case it is 100%, but practical case we cannot achieve the 100% effective 100% efficiency of any drive system because of the external parameter. Okay, but we should try to reach the 100% efficiency. Okay, so we can say around like 96-97% efficiency. Okay, so these are the learning outcome of this subject. Okay, so course learning outcome, so we can say we will cover the fundamental of electrical drives and control, that is a CO1. CO2 operation control strategy of AC and DC motor with the different coordinate operation. We have a 4 coordinate operation. Okay, we will see the 4 coordinate operation in the first unit. Okay, so these are the course learning outcome CO1 to CO5. Okay, we have a total 5 unit. First unit, that is an introduction of the electrical drives. Okay, introduction to the electrical drives. So it will take around 6 hours. Okay, so these are the just introduction of the electrical drives. So what type of loads are there? 4 quadrant operation we will see. Okay, and dynamic of the motor load combination, steady state stability. So that type of topic we will cover in the introduction to the electrical drives, and that is the first unit, and it will take around 6 hours. Okay, so this is a time period is a tentative. Okay, unit 2, that is a power electronics converter used in the electrical drives. Which type of power electronics converter we use in the drives, that we will see in the unit 2, and that will take around 8 hours. Okay, and most of the converters you already studied in the first semester, that is a power electronics subject, as Manoj Vargle told. So we already studied this power electronics converter, correct? Maybe some converter you not studied in the first semester, but we will cover in the second semester. Okay, so that is the second unit. Third unit, control strategy. Okay, so we have to implement different control strategy to control the speed and torque of the motors using the power electronics converter, correct? Ultimately we have to control the speed of the motor and torque of the motor, correct? So ultimately we have to control the electric quantity, there is a voltage and current, correct? So by power electronics converter we can control the voltage and current. Okay, so it will take around 10 hours. Okay, then unit third, that is a dynamic modeling and simulation. Most of the part we already studied in the first semester, but in unit 3, that is a advanced level modeling. Okay, we have to consider the many parameter to model of the your machine. Suppose like thermal parameter we have to consider. Okay, thermal modeling of the motor. In the first semester we did not consider the thermal modeling. Okay, we did not consider the temperature, but in the second semester we have to consider the temperature for the modeling of the electric machine, because your resistor is a temperature dependent quantity. Suppose you are not consider the temperature, then resistor will change with respect to temperature. Once the temperature will change, then current will change, because V equal to IR. So we have to consider the thermal modeling while modeling of the electric motor, correct? Then the type of duty cycle. So duty cycle is also the concept of the modeling part. Maybe the short duty cycle, maybe the long duty cycle, maybe the half duty cycle, correct? Yeah, intermediate duty cycle, correct? So we will also study what is a duty cycle, correct? And fourth unit, that is a sensorless control. Okay, what is the meaning of sensorless? Any idea? Did you heard about the sensorless in previously? Yes, any idea? Any student? What is the meaning of sensorless control? Any idea, student?
No, sir.
Okay, so sensorless means we have to control the speed, yeah, flux without any sensor. Without any sensor means, suppose you want to measure the voltage, then we use the voltmeter. Suppose you want to measure the current, then we use the ammeter, correct? So that is a part of the sensor. Suppose you want to measure the speed, then we can use the encoder, correct? By using the encoder, we can measure the speed. Suppose you want to measure the flux, then we have a flux meter. Sensorless means we cannot use the encoder and we cannot use the flux. We cannot use the flux meter. We can just sense the voltage and current, and then we can say our motor is operate like 500 rpm, maybe the 10,000 rpm, correct? So by measuring only the voltage and current parameter, we can calculate the speed, and that is a stand on the sensorless operation. So we can reduce the sensor part, we can reduce the circuit complexity. Then we can say our drives is a very small size, and that is a sensorless control strategy. Okay, so just we will see the controlless operation, how we can control the sensorless operation. Okay, and it will take around 4 hours. And final unit, that is application and case study. Okay, so whatever you get the knowledge from this subject, so that is a final unit, and that is application and case study. So real world application of electrical drives in various industry. Then case study highlighting the successful implementation and challenge. Whatever knowledge, whatever technique you learned, correct, from this subject, then we have to implement that strategy. What type of problem, what type of challenges we are facing, that is a final unit. Okay, so we have a total fifth unit, we have total 5 unit. Okay, unit 1, 2, 3, 4 and 5. Okay, and then one more component, that is a laboratory work. Okay, and that laboratory work, maybe you have to perform some experiment in the lab, because I already talked with Jitendra sir, and he told we have some drives available in the lab. Okay, so maybe you have to perform some experiment in the lab and some experiment in the MATLAB. Okay, so experiment based on the starting and running characteristics of the converter feed AC/DC motor. Okay, so we have to experiment, we have to do the simulation, we have to perform in the lab starting and the running characteristic of the converter feed AC/DC motor. Okay, second part, harmonic analysis. Okay, whenever we use the converter, obvious harmonics are there, correct? So we have to also analysis the harmonic. Okay, harmonic behavior of the AC/DC drive. And then V by F base drive, there is a variable frequency drive, and projects on the drives using the standard software. Okay, so suppose somebody want to do the project, somebody want to design the project, then also possible in the laboratory work. Okay, so these are the major components of the laboratory work, and it will carry around 20 marks. So maybe you have to perform in the lab whatever experiment available in your institute. So we will perform in the experiment and validate the result with the simulation. Okay, and simulation in the MATLAB. Okay, and these are the textbooks which maybe you can refer. Okay, so first one is a Dubey, that is a GK Dubey, Fundamental of Electrical Drives. I will share you, there is a soft copy. Okay, second one, there is again same author, there is a GK Dubey, that is a Power Semiconductor Control Drives. Manoj Wagle, do you remember which type of book you use in the first semester for the power electronics? Any idea? Yeah, any student? For the power electronics converter, which book you use?
Nedmon sir and Rashid.
Nedmon and RH Rasid, correct? Okay, good. So you can use also NAND and RH receipt for this power electronics converter. Okay, that is not issue. And third book we already studied, we already used in the first semester, that is a modeling, Keystone, that is electrical motor drives, modeling and analysis and control of the electric machines, correct? So we already used this third book in the first semester. Fourth book also we use, that is a electrical machine Fitzgerald book, okay? And fifth one, that is a power electronics converters and AC drives, that is a BK Bose, okay? So mostly you can refer my lecture notes, so you can get the knowledge, but suppose you want to learn the extra, then you can refer this book, okay? So we have total 5 textbook, otherwise we can say the reference book, okay, for this semester or for this subject, okay? Now any confusion, any query for this syllabus? Yes, student, any confusion for this syllabus? Yes, no query. Okay, just 1 minute. So no query, then just 1 minute. My presentation is visible.
Yes, sir.
Okay. So in the last semester, we already studied about this application of the power electronics and electric drives, correct? So why we have to study the electric drives and what is electrical drives, definition of electrical drives, correct? So we already studied in the previous semester, okay? So just revise. So electrical drives means we have to control the speed, otherwise the torque of the motor, then we can say that it is a electrical drives, correct? And why we have to control? Because we have a many application, air condition, ceiling fan, refrigerator, everywhere we have to control the speed and torque, correct? So that's why we have to design the electrical drives, correct? So we can see small application to big application. Maybe you can say the hair dryer, maybe you can say the kitchen application, the food processor, everywhere we use the drives, correct? So we can say the small application to big application, everywhere we have to use the electric drives, okay? And these are the major components of electrical drives. So we can say power processing unit, that is a converter, electric motor, any type of electric motor, then sensor parts, and then controller. So we can say major components of electrical drives, that is a 4 component. First one is a converter, that is a power electronics converter. Second one is electric motors. Third component, that is sensors. We have to sense the many parameter. And fourth one, that is your controller. Okay. So whenever we can say the major components of electric drives, then we can say we have a total 4 component. Also this slide we discuss in the first semester. Okay. Is there any confusion, any student, for this component slide, component of electrical drives? Any confusion? I hope there is no confusion for this slide, because this is a fundamental concept of the electrical drives. Okay. Yes. So key point from the today's class. So discuss the syllabus, course evaluation scheme, and introduction to the power electronics and electrical drives. So just we discussed the power electronics and electrical drives, what type of converter we use. Okay. There is a buck boost converter, boost converter, step up, step down transformer we can also use. In the electrical drives, we different type of electrical drives we will study in this subject. Okay. So any confusion, any query from the today's class? Yes, student, any confusion, any query? Okay. So if no query, then we can stop today's class, and from the next class we can start the unit first, and that is the introduction of the electrical drives. So our next class on the Monday, correct? Correct, Isa, am I correct?
Yes, sir. Yes.
Monday and Thursday, correct? One class
Yes.
is on Monday and another class on the Thursday. Okay.
Thursday.
So from the next Monday, I will start the first unit, and there is an introduction of the electrical drives. Okay, maybe the time period will change, but I am not sure. So depend on the timetable, because updated timetable again, Jitendra sir will share. So maybe the time slot will change, but I am not sure. Depend on the Professor Bharati Rajpurohit timetable. Okay. So I will let you know. Suppose timetable will change, then I will let you know. Otherwise, same time we will meet again on the Monday. Okay. Done. Okay then. If you don't have any query, then you can leave it. No issue. So today's class is completed. Okay. So we will meet on the Monday. And I will share the I will share the lecture notes as well as the syllabus as well as the book in the WhatsApp group. Okay. Done.
Okay, sir.
Okay. Okay then. Bye bye. Good night. Take care.